Good afternoon, everyone, and welcome to AMPC's webinar this week on funding refrigeration energy efficiency. Today we've got guest speakers Michael and Frederick to be able to talk through everything refrigeration and how that relates to the red meat industry. For those that are new to the system, we really encourage questions. So please feel free in your chat to type your questions, and then we've got a couple of question spots throughout the presentation where either Matt Deegan or myself will ask the questions to the presenters. Welcome to today's session, and I'll hand over to Matt Deegan to give you a little bit more background around the project and what's brought us to this webinar. Thank you.
Thanks, Amanda. Welcome, everybody, and welcome to our presenters, Michael Belstead and Frederick Eagers from -40. So just the background as to why we're doing this webinar and some previous R&D. Well, we know that every plant uses refrigeration, and we know that it's our single largest user of plant power, accounting for about 40% of total plant energy, actually. And our 2020 environmental performance review tells us, the results tell us that refrigeration energy efficiency is still being neglected. And we know that because sectoral energy intensity has risen since 2015. It's risen by 43% if we exclude rendering, and it's risen by 10% since 2015 if we include rendering energy. So you can clearly see that the 43% rise includes or excludes thermal energy mostly, so that electrical energy intensity is rising at a very rapid rate. I think the reasons for that could be to do with increase in retail ready type packaging and more energy consumption for refrigeration. So we ran a core project, -40 ran a core, managed it for us, core project on refrigeration energy efficiency opportunities, and there was about a dozen workshops run across the country with members, and it also confirmed that there's low levels of adoption for refrigeration energy efficiency, and we can see that in the graph below. That triangle is adoption hierarchy graph, and shows that at the base of that triangle, where you have essential type actions for energy efficiency, only 60% of members are doing that. Those are things such as granular monitoring of energy. If we move up the adoption hierarchy, the next level to hard yards, which is around water and air purging, for example, replacing worn compressors or staging compressors, we see that 30% of members are doing that. If we go up further towards the apex, we see the next adoption hierarchy is around speed controls, variable head pressure control, economizers, heat recovery, etc. That's around 10% on the adoption level. And at the apex, the top of the energy efficiency adoption hierarchy, we have integration. So that's around predictiveness, Industry 4.0, heat pumps, demand response, etc. And there was no adoption at that level during the observed during those workshops. So Michael will go through that project, as well as an exciting part to this webinar, which is around funding options to help adopt energy efficient refrigeration. So I'd like to hand over to Michael.
Thank you, Matt. Thank you very much. I am going to do this presentation, as Matt said, in two sections. The first one will talk about the project, and the second one will talk about refrigeration as a service, which is the exciting option being taken up very much across the planet. So let's start off with the project that we're closing out at the moment. I'll quickly talk about the objective of the project. We'll show the transition that the industry is going through on the energy side, which is impacting heavily on the refrigeration. The 4 stages of energy efficiency, which Matt has already alluded to. The overview of the EEOs that we've identified, interesting learnings there. The small versus medium large site subject, and the state of the industry and the barriers that we've seen preventing take-up. Then we'll move on to RaaS, or Refrigeration as a Service in long. What it is, how it works, how it can actually fix many of these challenges quite elegantly, what it takes to work it out, and then the proposed core project that may interest the members. Right, so let's start about the project first. So the project's objectives were to develop a set of guidebooks, manuals to go with the guidebooks and tools, and these will be published soon. The objective was to help the site engineers, not to help the external contractors, but to help the engineers identify EEOs, or identify, quantify, and assess the EEOs. So it was a tool aimed at the processors rather than the service providers. We had multiple interactive site workshops, which were really good because they made us change direction a few times. And yes, we'll talk about the EEOs, the energy efficiency opportunities, and the new technologies a little bit. Yeah, so looking at the energy transition, meat processors, more so than many other refrigeration users, have a whole spectrum of heating and cooling needs on every site. So part of those traditionally, or shall I say yesterday, were met by refrigeration. So everything below 10 degrees or 10 degrees and below is done by a refrigeration plant or multiple refrigeration plants, all the way down to blast freezing or plate freezing. And then everything above ambient is done with a boiler, where you burn some form of fuel, be it coal, diesel, natural gas, LPG, or biomass. Now that cannot stay that way, because in the carbon constrained future, we have to move away from burning carbon fuel. So the future looks different, and the future is very much involving refrigeration, where a lot of the heating work currently done by boiling fuel is done by recovering the heat from the refrigeration. Certainly things like hand wash, wash down, and scalding or sterilization is quite easily done with modern refrigeration technology, either using heat recovery from an existing plant or by incorporating heat pumps into the solution. And only for steam, for rendering type applications is an actual fuel burning still required. And even that may be overtaken by high temperature heat pumps in the more distant future. So the industry is in transition, and we need to consider that, consider energy efficiency opportunities from that perspective. We can't just stay where we are, we actually have to move forward. In that light, all the energy opportunities or the energy savings come in different styles. Some opportunities save kilowatt hours, they save electrical energy, and these are your classic refrigeration plant opportunities. And then where you use the refrigeration plant to offset fuel use, you save gigajoules of energy. This is where you offset gas or coal use. And then there's a third element to savings, and that is when you reduce your network charges. Meat processors have a very lumpy way of using energy, so their network charges are comparatively high compared to, for example, cold storage applications. And you can save good money by saving your peak energy use. That's where demand management comes in. And then there are some opportunities that actually do more than one of these things at once. So that is an interesting recognition. Not all energy saving opportunities do the same thing. In the process, and particularly with the large ammonia plants, we learned that yes, there are a lot of energy saving opportunities, but they all come in certain steps, and some follow on each other, and some you can't do before you've done others. So there are a number of basic things you need to do, and you need to do those first. And those we've coined the term the essentials. Some of them are really just housekeeping things, and some of them are the first basic steps to make your plant efficient. Then come the hard yards, and these are stuff like replacing worn out pieces of kit, or doing the major investments that get your plant up to the fundamental level where you can start doing the next step, which is the refinement. Refinement are all those nice polishing aspects, as we say, but it's no point polishing something which is fundamentally run down. So you've got to do the hard yards first, and then you do the refinement. When you reach that point, now you can start integrating it and start recovering heat and integrating heat pumps to offset fuel use. So there's a certain logic. You don't do the integration things right up with a plant that doesn't give you the ability to do so. And we've termed the enablers and followers. This is a very handy terminology. So there are some things that you can't do before you've done others. Now, the specific example there is the use of economizers on screw compressors. Now, they're great. They definitely save energy. They're a good idea to put on, and there are some sites that have them. But if you don't have a speed drive on that compressor, you're actually not achieving any energy savings. So in that case, the variable speed drive on your compressor is the enabler, and the follower is the economizer. And some followers, some opportunities have multiple enablers, and we need to understand this. And we've unpicked that in the guidebooks which will be published. So it's important to understand that. Don't get ahead of yourself and start doing refinements which don't then give you the benefit because you haven't done the enablers prior to that. A very common problem. It's very pity to invest money and then not get the return because you haven't done the enablers for that opportunity. So raw statistics, we've stabilized on 35 total identified and usable opportunities. It was interesting. We actually threw a few out which we found were not really that applicable, and we brought a few in which we thought would not be. So we have a total of 25 energy efficiency opportunities, which will be detailed in these guidebooks, and 10 new technologies, which are relevant to both small and large sites, which go into what we call the new technology handbook. Of these 25 energy efficiency opportunities, 10 of them are applicable to small Freon sites. 23 of them are applicable to medium and large ammonia sites, so there's more. That's perhaps because ammonia sites are more flexible. And of these opportunities, 7 of them are essential, 9 are hard yards, 7 refinements, and 5 are the integration. We don't have time to go into the details of these, but it all worked out pretty nicely that there were steps along the way. So we conducted a total of 10 workshops, 2 on small sites, 4 on medium sites, and 4 on large sites. So that's the sort of the gross summary of the project. Now, the results we learned, or the learnings from these sites, besides obviously learning about opportunities and what opportunities work, and that was the objective of doing the workshops, we also could see how far the industry had progressed. And of these 10 participating sites, only 6 had even progressed beyond the essentials, were doing anything that wasn't basically an essential. 3 had implemented some of the hard yards, and 8 of the 10 had implemented some of the refinements, noting that some of the refinements were implemented on sites that hadn't really finished the essentials. But most of these sites were only a single one of the many EOs that were possible. And unfortunately, none had integrated that. None of the sites that we were looking at had functioning heat pumps or any advanced technology, heat recovery, anything like that. So the highest performing site had 36% of the EOs implemented that could have worked on the site, and the average implementation was like 17%. Now, why is that? Why is that? Energy costs a lot of money, so why aren't we implementing the opportunities? Many of them are old hat, they are well understood. And it's really, I guess, these fundamental efficiency challenges are faced throughout the sector, and there are a few common reasons. The one is your typical meat processor is exactly that. He's a meat processor. He's not an expert in refrigeration design, energy efficiency, servicing and repairing refrigeration equipment. That's why he has a service provider often that does that for him. So it's not his expertise. He's a good meat man. Then, because of that, partly, it's not that the sites are not necessarily good at identifying what is the lowest lifetime cost of a specific energy efficiency opportunity or what is the best solution. how can they? It's not their expertise. And then finally, this is maybe somewhat controversial, but at the end of the day, the meat processors depend on their advisors, which is typically the incumbent refrigeration contractor. And this is where the incentives come in, because at the end of the day, the contractor has to run a business. He doesn't have to pay the energy costs that the processor has to pay, and he needs to run a business and doing maintenance as part of his business. So the incentives don't necessarily align. So that's where we got to, and read more in the guidebooks. Any questions thus far?
I had one question, Michael, while you're there. There was a slide on project statistics where you mentioned there was 35 identified energy efficiency opportunities, and 10 involved new technologies, such as the heat pump. When you say new technologies, we're saying this is new to our sector, aren't we? We're not really saying it's because the food manufacturing in Australia has already done some of these technologies, adopted some of these technologies, haven't they? So they're not. Is it as if they are brand new, or they're just not part of our sector at the moment?
Yes, it's maybe a better word would be unfamiliar technologies. So absolutely, these are technologies which some of them are decades old. They are just not widely used in the meat industry, and they potentially already are widely used in other industries, and they certainly are quite widely used overseas. So that's correct. So the new technology just highlights opportunities that are fully commercialized. So that's the point. There are things like high temperature heat pumps, which are not yet fully commercialized, and these are not in the new technology handbook. We've only covered fully commercialized technologies.
Okay, thanks, Michael. Anyone else have questions? Please feel free to put them in the chat, or send them through on SMS, etc. Only one question for you so far, Michael. I'll hand back.
Okay, no worries. Good. So now let's talk about refrigeration as a service. This is a very exciting new way to deliver refrigeration, which is being encouraged worldwide, and is being done a lot in Europe, and oddly enough in South Africa, where you probably would have heard that's where I originally come from. So what is refrigeration as a service? So refrigeration as a service, well, first of all, we need to understand the Capex, the capital expenditure versus operating expenditure, that challenge. We need to understand what business as usual is and the problems associated with that, which I've already alluded to. Then understand what is different with the RaaS business model. What are the key elements that a RaaS model has to have to work? What it takes to actually develop a RaaS model. And it is of particular, it's quite difficult doing that for a complex meatwork site, so it's not necessarily an elemental thing to do. There are contract variants, which in fact we won't go in and on this presentation in much detail, and then we'll look at a few examples to show you what has been done and the conclusions associated with that. So Capex versus Opex, and this is a classic example. So there's the tendency to take capital decisions or to take investment decisions on the basis of Capex, and quite typically, but not always, lowest Capex gives you the highest energy cost. And with refrigeration, that is very, very much so. So on a refrigeration plant, your energy cost over the lifetime of a plant is somewhere between 60 and 75%. This is well understood. So it is the bulk of the cost of owning a refrigeration plant is the energy cost. Your Capex varies somewhere between 15 and 20%. So even an expensive ammonia plant will only cost you 20% of your lifetime costs. But a 20 to 30% increase in your Capex might actually reduce your energy costs by as much as 70%. As big as that, it's quite stunning how big that number can be. And then if you put all those numbers together, it means that a 4 to 5% payment of total life cycle costs up front actually saves you 50% of your total life cycle costs. So that's kind of crazy. You know, obviously everybody would do that. You put 4 to 5% extra down to save 50%, but yet it's very rare that it's done that way. Now, what are the problems that lead to this? So often the buyer buys on price, and that's what everybody defaults to. You buy on price if you don't have good advice or you don't have plenty of capital. And we often don't have good advice or we don't have plenty of capital. Then also the installer doesn't pay for the energy. So what you're being offered is not necessarily the one with the cheapest running cost. It is possibly just the one with the lowest capital cost. Then often the installer profits from after sales service. So you'll find that many installers will make more money on the after sales service than they will on the actual installation. And then the key point is the owner actually wears the full risk of the energy cost and of the maintenance cost and of equipment breakdown. So if poorer quality equipment is put in and it causes more breakdown or more maintenance cost, that is the owner's problem and not the installer. So you can see the problem with normal refrigeration ownership rules is that your incentives are not aligned. This also applies to other things like boilers and compressed air. It's not unique to refrigeration, but it's particularly aggravated with refrigeration because of the complexity of it. So the RaaS model covers the following 5 key points, and it has to cover all 5 to work. So first of all, there's ownership. Then there's the cost of the power. There's the cost of the capital and the maintenance. There's the cost of the refrigeration, the actual cooling or heating produced. And there's the thing about the availability guarantee. How do they all mesh in? So, who owns the equipment? Now, the RaaS provider must own the equipment. He owns everything inside the plant room, typically also the room evaporators and the connecting pipe work. And he may or may not even own the plate freezers. Typically, high expense refrigeration using equipment can be excluded from the contract. It doesn't always make sense. So he owns it, and therefore he can do with it what he likes in a sense. It's his property. The customer has an anytime buyback option. So if after 3 years into the contract, they want to revert back to conventional ownership, they just pay a defined price and it's theirs. This is important because the owner must be able to sell the facility or do something like that, and he must be able to exit from the contract potentially to do so. So that's it. Who pays for the power? Now that is clear that the RaaS provider pays the power. So all the refrigeration equipment that he owns, he pays for the power that he uses. This can be quite complicated if an existing plant is taken over because you need a lot of different meters. But at the end of the day, the customer is reimbursed at whatever the tariff rates are at that time. So this incentivizes the RaaS provider to use less power because he's paying for it. Then Capex and maintenance costs. Now, these are all on the RaaS provider. So he has to finance the plant. He has to pay for maintenance and breakdown. So if he runs the equipment into the ground and it breaks, it's his problem. And therefore, he also has to cover the insurance costs. And it's up to him how he insures us or whether he insures it at all. For all of that, the customer pays a fixed availability fee. And that fixed fee is for the duration of the contract. It can be fixed totally, or it can have an escalation, or even in some cases a de-escalation clause. That is really a financial decision. So typically it's a 15-year contract, and the fee will be fixed or escalate slightly at annual increase, whatever. So this incentivizes the RaaS operator to minimize maintenance and breakdown costs. So he won't maintain unnecessarily, it won't do unnecessary preventative maintenance, which won't give him a benefit. But on the other hand, he won't under-maintain the equipment to cause it to break down because that's at his cost also. Cost of cooling. Now, this is, of course, something that the customer has to pay, so the processor. And that is measured. So the amount of cooling that is consumed is measured, and I won't go into the details of how it is measured, but there are agreed ways in which heating and cooling is then measured. and that's charged on a monthly basis back to the client. So if the client uses a heck of a lot of cooling and leaves freezer rooms open, he pays for it. So this incentivizes the client or the processor to use his energy sparingly, his cooling sparingly. This cooling, the rate at which cooling is sold, is then reviewed annually. It has to be reviewed annually because the power costs might change. And if power costs go down, then the rate needs to be reduced. And also, if the usage of the refrigeration system goes down, if the processor goes from 5 to 3 day production, then the energy rate will go up. Conversely, if production increases, the energy rate or the cooling rate will go down. So this has to work that way. There has to be that compensation and annual adjustment. And then finally, there's the availability guarantee. So if refrigeration is unavailable because a plant is broken down, and if temperature in rooms is not maintained, then there is a penalty clause, which is a financial penalty, which is a discount on the monthly bill or a credit to the monthly bill. And of course, if the plant is down, the meter stops, and then the RaaS operator stops earning money. So there's enough incentives built into these contracts to make sure that the RaaS operator keeps the plant running. So those are the essential bits that you have to do. At this point, after the basics, any questions at this point on the principle of RaaS?
I've got another question, Michael. While we're waiting for anyone to put questions in the chat.
Yes.
This is the part that I am always interested in. Is the assessment of the Capex versus Opex, or your lifetime costs, assessment of lifetime costs for refrigeration. There's a seminar after this, isn't there, where you'll be going into some of the tools that you've developed to help that comparison of lifetime cost versus upfront cost?
That's right. We'll be doing a seminar which will do two things. So the one is we'll look at the tools in more, because we can't present them now. We'll present the tools which will be available, which will show you how some of the opportunities actually do become commercially very attractive. But we'll also do at that seminar is go into the detail of more detail on a case study. We will look at the numbers for a RaaS site.
Thanks, Michael. And anyone who's attending today who wants to attend that seminar for an individual assessment and via that tool should get in contact with either myself or Amanda after this webinar. And then I had another question. Since no one else is asking questions, Michael, I've got another question. The thing I really like about RaaS is the alignment of the service provider with the end user, in that the service provider pays the power, the maintenance, the insurance. So they want to get those costs down. So that's where the alignment is, isn't it? Will you go into that in a bit more around the agreed schedule that documents that in the seminar?
Yes. There obviously is a lot of that, and there are also variations in terms of the way the contract can be structured, which they have to be just to make it work for everybody. Yes, there'll be a lot more detail discussed about this, and please, hopefully, a lot more questions asked during that seminar. Okay.
Thanks, Michael. I think that's a key factor, the alignment of interests around refrigeration as a service. Thanks.
Totally. Yes. No, I agree. That's to that question. Going into a RaaS contract is a bit like getting married to somebody. It's a long-term commitment. And it's not just a financial commitment, but it's an ongoing relationship that has to be maintained for 15 years. Okay, now to set up a RaaS model, a few key things have to be understood. First of all, the capital cost of the refrigeration plant. Now, refrigeration plants for meatworks are very complex because they do very many different things. So doing that Capex cost, either of a complete replacement plant or taking the plant and upgrading it, is not a simple exercise, and it needs to consider exactly all those factors we just spoke about, the payback on each opportunity, and what is the net lowest operating cost that you achieve. So the capex, and to do the capex, you need to understand what the energy usage is. You need the energy usage. Well, you need the cooling usage and the energy usage. You need to understand how much cooling is produced, and you need to understand what the energy use is. And then finally, you need to understand what the maintenance costs are. So once you've established that, which all are interrelated, then that can be converted into a proposal which gives you the capital and the fixed cost and the running costs. If you don't do that carefully enough, then somebody loses, either the RaaS operator or the processor, and neither is a desirable outcome. With the way you want it, a successful RaaS model is one where both parties are benefiting from it. But certainly, we'll go into more detail on this during the seminar. There is a lot of curly things that one has to consider, and rightly so. So a case study. I've got two case studies. Both of them were done in South Africa, because RaaS in Australia has not yet been done. So this one is a food packaging company, and quite a classic example. They actually had an ammonia glycol plant serving a number of cool rooms, which was aging and going out, and they were seeking a low-cost replacement. So they were seeking a replacement, in this case, with a 407F refrigerant rack solution, which would have been cheaper than supplying it with an ammonia system, but clearly it would have been an energy penalty. So instead, they signed up with a RaaS contract to upgrade the ammonia plant. So they, not a huge project, but they had a $300,000 avoided investment. So Afrupro, they didn't have to spend the money because it was paid for by the RaaS provider, in this case, Energy Partners. But as a result, there was significant direct and indirect annual emissions because we stuck with ammonia and didn't go to 407F. And of course, there were the energy savings. So the energy savings that were achieved enabled Energy Partners to make some money, and Afrupro had lower running costs and less investment as a result. Then the meat processing example was a company called Lynca Meats. They're actually a pork processor. They had a large number of cool rooms and freezer rooms, classically with the little R22 refrigeration units, not an ammonia plant. These units were 20 plus years old and were a worst case scenario. So in this case, as an interim solution, a 407F rack-based system was put in, which gave a significant energy savings over the R22 units. So the annual savings directly to Lynca Meats was $115,000 a year, and yet Energy Partners was making money out of that. And they're doing an expansion to the entire site to ammonia at the moment, and we're hoping to report in greater detail on this case study in specifically during the seminar. So here's a client quote. There's a general manager of Lynca Meats saying, "Managing the refrigeration requirements of a facility of this scale had become increasingly time intensive, requiring specialized knowledge." Classic situation. "We realized that handing this managerial responsibility over to outsourced specialists would therefore be in the best interest of the business, as it would allow us to focus solely on the company's core activities." And that really is a theme that most RaaS participants are repeating, is hand it over to somebody who knows what they're doing, and then I can focus on my core business. And that's what Lynca Meat looks like today. So not only did this contract include refrigeration, it also included solar. And in this case, the solar and the refrigeration is being operated by Energy Partners. It makes a lot of sense actually doing it that way, because the solar power is then basically inserted behind the meter. So the savings goes to Energy Partners, and therefore they're also incentivized to keep the solar panels running perfectly. So they'll be the ones going up on the roof cleaning the panels and not the processor. Yeah, So RaaS is essentially a modern outsourcing model, and in some respects it's similar to a solar model, where solar PPA, except it's logically more complex. But it is particularly well suited to meat processor installations due to the complexity thereof. So it allows the processor to focus his capital, time, and resources on his core business, which is processing meat. And the RaaS provider assumes the costs, the risks, and the responsibility of the refrigeration plant operation. So the RaaS provider makes his profit by removing inefficiencies, not by selling equipment or selling maintenance, but by, in fact, avoiding maintenance where it's not necessary and reducing energy costs. That's the margin that he can control, and that's where he makes his money. Ultimately, the best way to do this is with quality and energy efficiency equipment. So those suppliers have the benefit thereof, which is good for the better refrigeration contractors who are able to do this. And ultimately, the processor has the lowest net costs, because now he's in spite of the RaaS provider making a margin, he's still paying less money than he used to pay, and he has less for it. So, any questions thus far on this bit?
There was a question, Michael, from Graham, and I think I've already answered it correctly. I'll read out Graham's question. Graham says, am I correct that there is then a capital lease component to cost and a separate cost of refrigeration component?
Yes, that's correct. So there is a fixed monthly capital and maintenance fee, and then which is fixed or escalating for the term of the contract, and then there is a usage cost, which is dependent on the amount of refrigeration used by the processor.
Good. So that allows for the variability in the usage.
Correct. So if the processor, goes down to 3 days processing, then he will also pay less refrigeration because he's using less, and so the RaaS processor will pay less power, and that'll be compensated for by less income as a result, of course. So yeah, there has to be that natural balance in the contract, and it's done that way.
And I hope that answers Graham's question. I know you used the words, Graham, capital lease component. Just as a reminder that the service provider owns the equipment, so they have any finance liability. There is no liability regarding finance for the end user. That's correct, isn't it, Michael?
Well, that's correct. It's fully owned by the RaaS provider. So yes, unless the processor buys out the contract, he in fact doesn't own the equipment. So really, the RaaS provider could pick up the equipment and go away with it. Of course, he wouldn't do that, but it is his equipment, and he's therefore fully responsible for it.
Yeah. Thanks, Michael. Sorry, you were going to say something?
No, all good. The question.
The Lynca Meats one, I was just interested to know that with all the solar on the roof they had, what percentage of refrigeration power did that? Do you know how much that was covering? Obviously, all of it, but
not off the top of my head. I've got the numbers somewhere, but I wasn't ready for that question.
Okay. It was just interesting that they used every bit of available roof space.
Well, totally. Yeah, look, I mean, it's kind of obvious because these RaaS contracts normally run over at least 10 and typically 15 years. And we know that solar payback is in the order of less than 7 years. So it kind of is nearly logical to include solar into a RaaS contract, because it almost always will be of benefit to the RaaS provider. So unless there are other reasons, unless there's not enough roof, or the roof isn't strong enough, or there could be technical reasons why you couldn't do that. But if there is plenty of roof space, it is a logical improvement. And if it's done from the beginning, it's factored into the refrigeration rate. So the cooling rate could actually be lower if the whole contract then includes the solar. So it is, again, to the benefit of the processor to throw that net a little bit wider. So it could be something that could be included in some cases. Not always is it a perfect fit.
Right. Another question there, unprepared question, Michael. So I don't know if this is a trick one either. But who's responsible for the emissions attached to a scope 2 emissions when it's owned by a service provider?
Yeah,
the refrigeration scope. Who accounts for that?
Yeah, good. I think it will still be the responsibility of the site. So because it's location based, to my knowledge, it's not. Although the equipment is owned by the RaaS provider, it is on that side. But good question, which I'll take on notice.
It's interesting because this refrigeration as a service has an energy efficiency benefit, so that therefore should have a emissions benefit to the end user, I'm assuming.
Well, it does substantially reduce the carbon emissions for the site. So that is clear. How that is done let me answer that question during the seminar.
All right, thanks. Another question. This is the third different, not one of my questions. Do you know if the refrigeration as a service provider tends to be an energy provider or a refrigeration company?
It can be both. So normally it's an energy provider with refrigeration skills. The RaaS provider typically himself outsources the refrigeration installation, but because he's managing the refrigeration, he must have the skills to manage it properly. So it's in the case of energy partners, for example. Let's just use an example. They are actually a larger energy company. They also do boilers and other provision, but they have a division. They have commercial and industrial refrigeration divisions as well. So it doesn't have to be that way. I know that other providers in Europe are pure energy companies, and they have the managerial skills, but then they bring refrigeration contractors in as needed to do the installation work and the service work. So they effectively become something like a facilities manager in a sense. Okay, so they become an owner and facilities manager.
Right, thanks.
Okay, so yes, that's not quite. Well, I just wanted to introduce the core project. So we'll talk about that now. So the proposed core project will have up to 3 participating sites, and the idea is to demonstrate the viability of RaaS in the Australian context. And there will be an installation of a monitoring system that is needed to understand how what the site is consuming at that moment. It will then involve the engineering scoping of replacement, either replacement or upgraded refrigeration system, which will then be designed for lowest net costs. Then it will lead to the preparation of a comprehensive RaaS proposal, which will then give the site the option to either proceed with that or to do conventional ownership or upgrade work based on the design. So this is a call to sites to submit an expression of interest to participate in this core project. And if we have more than 3 expressions of interest, the surplus applicants we will direct towards the ARENA Energy Transformation Project when this goes live. It's currently on hold. That will provide a similar support, but on a somewhat longer timescale. So the proposed next steps, therefore, are the core project, as I described, with the 3 sites and the surplus applicants going to the ARENA funding, the RaaS offer, and then the core project, which will assist with the adoption and the verification of this. Right. So we are calling on interested parties to register for the Tooling Up seminar, which is a date to be advised. So we're aiming to structure this in 2 sessions, covering first of all more detail on the project that I've mentioned. We will go into a bit more detail on the drivers behind it and also on synthetic refrigerants and why these are even more on the way out than they were 18 months ago. And then more detail on RaaS, on a specific case study, more Q&A on how RaaS works, and I'll respond to that question that was answered, and more Q&A on how the expression on how this core project might work. So if anybody's interested in that and interested in the expression and expressing an interest for this, please contact Matt. Thank you. I'm done. Matt, over to you.
Thanks, Michael. And I'd just like to thank everyone for attending today. If there's any further questions, please send them through to myself or Amanda. Just the next steps I'd just like to highlight again is that the next step for any interested attendees here is the Tooling Up seminar. And the Tooling Up seminar is really the hands-on bit where Michael and -40 and Frederick can demonstrate the tools that have been developed to help assessment for energy efficiency opportunities. And those tools have had about 12 months worth of work go into them, and they really are assessing lifetime costs and looking at energy efficiency opportunities in the correct way that they should be looked at, rather than just in terms of Capex. Of course, Capex is only just one part of it. And also at the Tooling Up seminar, the refrigeration as a service, Michael will go into that for interested members in more detail. So yeah, the first bit is the Tooling Up seminar, which we're taking interest in attending that for now. That could be in the next week or 2, and then after that Tooling Up seminar, we may already be closed on the EOI, not sure, but whether we need an EOI or not, we'll decide after the Tooling Up seminar. So I'd like to thank you, Michael, for your presentation. Interesting and innovative as usual. And I'd like to hand back to Amanda. Are you there, Amanda?
Thanks, Michael and Matt, for a really interesting session today. It's very much a different concept, so it'll be interesting to see the engagement from industry moving forward in this space. So hopefully you'll get some good attendance for your next steps. That concludes today's webinar. Just a shout out for next webinar is on the 15th of September, and we're actually changing complete tact, and we're going to have Carly Phillips from Corporate Wellbeing talking to us and having a very interactive discussion around a wellbeing program for the red meat industry and what industry wants to see in a program. So if you've got anyone interested in that, make sure that they register, and that's on the 15th of September. Thanks everyone for joining, and enjoy your afternoon and stay safe.
Thank you.
Thank you.